Hello, I'm Chase. I'm a co-founder of Decentology.
Hi, I'm Nick. I'm also a co-founder of Decentology.
So today we are super excited to host this workshop. Thank you to everyone who has signed up and made it, whether you're watching live or you're watching later on. We are super excited to share with you how you can build dApps on Conflux in 15 minutes. So this is going to be a workshop to sort of show you how to use our tool, Dap Starter, and ultimately share some exciting news around Dap Starter and Conflux. So as I mentioned, Nick and I are both co-founders. Nick is a serial entrepreneur. He's built amazing developer tools, and that's exactly what we're doing at Decentology. So we're on a mission to onboard the next 10 million developers into the blockchain space, and we're so excited to be part of the Conflux community and help onboard developers in building blockchain applications on Conflux. So our platform to do that is called Dap Starter. And essentially what Dap Starter allows developers to do is go from having absolutely nothing to a full stack blockchain application in 15 minutes or less. And when we say full stack, we mean sort of four major things. We mean the smart contracts, of course. We provide a server-side API. We provide the web UI for the front end. And then we also provide unit tests. So it's really everything that a developer needs to get started building blockchain applications. And we support several different blockchains. We're super excited to be supporting Conflux. We're very excited about Conflux bridging this gap between Eastern and Western projects in the blockchain space and really empowering developers to build awesome applications in DeFi and NFTs and sort of the entire space. So the basic way that Dap Starter works is a developer goes to our website, which is dapstarter.decentology.com, and they can choose different feature modules. So feature modules are very specific sort of functionalities that you want your dApp to have. So an example might be having an ERC20 token, or maybe you want to have file storage with IPFS, let's say. And then you sort of go through all of these different feature modules, configure the exact dApp that you want, and then you create your project. You can go ahead and download that. We'll create a custom GitHub repository for you. And then you can download it and develop, edit the code, do whatever you want. But the main sort of piece here is you can change all the code, but it works from right out of the box from the start, which is really sort of the core special part about Dap Starter. We like to say that we give developers 80% of what they need, and they just have to add their 20% special sauce. So there are four key benefits that we like to outline about Dap Starter. The first is that it's built for Web 2 devs. So it's not sort of expecting that developers know everything about blockchain, though, of course, Web 3 devs can absolutely make use of Dap Starter. The second piece is modular architecture. So these feature modules really allow developers to customize the dApp that they want to build. We're not trying to give you sort of an out-of-the-box template. We're really trying to help developers start from a place that is custom and then go ahead and customize from there. And ultimately, all of this saves developers time. We orchestrate everything on the back end with Conflux, Truffle, and all of these different pieces that Nick will show. And that really saves developers time. We understand the frustration of building dApps, and so we want to reduce that friction for devs. And we want to make sure that we're sort of giving you something to play around with and build on top of, instead of forcing you to deal with all of these small pieces that ultimately can add up and make things a little bit challenging when it comes to dApp development. So all of that being said, I'm going to go ahead and hand it off to Nick. He's going to walk through how to build a dApp with Dap Starter, and then I'll come back and share a little bit about what's next for the next couple of weeks.
Super. Thank you so much, Chase. I'm going to take over here and share my screen. All right, there we are. Okay, so let's begin by first going to the Dap Starter website, which, as Chase pointed out, is dapstarter.decentology.com. So when you come to this website, it's a standard SaaS application, software as a service application. And what we do here is you make some choices, and it's going to produce the full stack source code in a brand new GitHub repository for you. So let's go ahead and do that. So we're going to choose Conflux. And some blockchains support multiple languages, and I think Conflux is working on a couple more, but Solidity is the default. So if you're a Web 2 developer, don't be afraid of Solidity. It is challenging, no doubt, but it has very much a JavaScript and a C flavor. So you will be able to make sense of it, and you will be able to understand it. And having code that's heavily commented and already working is a big help in that direction. Once you choose the language, you then choose the framework. And we support Vanilla.js and React, and we'll add more in the future. For today, I'm going to use Vanilla.js. I'll just point out that most of the web UI stuff that we do actually is based upon web components. So it really doesn't matter which framework you choose, it'll work. And now this down here are the modular components that make up the project. So what we try and do is we abstract very common design patterns used in smart contracts and decentralized applications and put them here as a module. So you can make choices for any combination of modules that you wish. And what we will do is we'll go ahead and generate the code for you. So today I'm going to choose some very simple things so we can kind of get started and not have too much complicated stuff to deal with. So I'm going to choose a contract run state. So this is a module that enables a very simple functionality, the ability to pause and unpause a contract. Why would you want that? Well, sometimes you find a bug in your contract and you want to prevent people from accessing or running transactions on it. And so you use the run state module for that. Let's go ahead and also add a file storage module. So we support multiple decentralized storage options. IPFS, the Interplanetary File System, is one of them. I'll make that choice. Now, on some of these modules, you get a follow-up question or other parameters you have to provide. In this case, what kind of upload capability do you want? We'll choose multiple document upload. And you can make whatever choices you want. And at the end of it, you give it a name. So I'm going to call it Conflux Workshop. And then hit Create Dap. Now, this takes roughly a minute or so. And what's going to happen right now is that on our server, we have an intelligent code processor called Hypergrep that is making decisions based on what you have chosen. And if you're a JavaScript developer, you're probably familiar with how some of this works with NPM or Yarn. It figures out the dependencies, etc., and pulls it all together into a nice little package. So in about a minute, it will be done. And then it's going to create our GitHub repository for us. So while it's doing that, it's done. So here we go. We have a new repository on GitHub. It'll have a unique name. I'm going to go visit it. So this repository was created just for me just now. And what I want to do is draw your attention to the README here. It has the important prerequisites that you need in order to get started. And there aren't many. These are prerequisites that you probably already have. Visual Studio Code, Node.js, and Yarn, because we use a capability of Yarn called Yarn Workspaces, along with Lerna, which is essentially a framework that allows you to manage packages together. So installation is very simple, and we've got some troubleshooting hints also if you run into some problems. But for now, what we can do is simply copy this URL for the repository, and then we are going to clone it. So I'm going to switch over here to the right-hand side where I have my Visual Studio Code all ready to go. And I'm going to say git clone and paste that. So that's going to clone the repository. Let's go ahead and open it. And there it is. So we'll go ahead and open it. So I'm going to adjust these windows just a little bit so you can see more on Visual Studio. All right. And I'm also going to zoom in a little bit so it's easier for you to see. All right. So we have all the source code here. I'm going to go through it in a fair bit of detail here. But what I want to do is, before I get started, I'm going to have the dependencies start to install so that we can make efficient use of our time. So for that, I'm going to bring up a terminal here, and I'm going to type in the first command, which is to get all the dependencies, which is yarn. So this is going to start downloading all the dependencies. And while that happens, I'm going to briefly go through some of the packages here. Now, one thing I must warn you is that the Yarn, the version that is current and most popular right now, does not have a good way to suppress warnings. So you're going to see a ton of warnings here. Nothing to worry about. It is perfectly normal. You can ignore them completely. All right, so let's look at our packages here. So we have two main folders, packages and workspace. Workspace is sort of the Dap Starter tooling. As you will see once we have the web UI, etc., that there is an area for you to work in. So that's all workspace. You can completely ignore it. The work you will do is in the packages folder. And if you expand it here, you will see that there are three main folders: client, daplib, and server. So what we've done is essentially divided this. So a bulk of the code is in daplib. It has your contracts and other things. Client is the front end UI, and server is the back end. Meanwhile, this is done here. So what I would be doing next is running yarn start. But before I do that, I want to take a moment to kind of let you know a couple of things that are unique to Conflux with respect to Dap Starter. So when we have a blockchain integrated with Dap Starter, we usually make a choice on whether we should use a local blockchain emulator, so you can do your development locally, or if we use a testnet. Now, with Conflux, we found that the developer requirements for running a local emulator would put it out of reach of a fair number of developers. It would take also a fair bit of time to get it going. And so we opted to run with the testnet. Now, when you run with a testnet, one of the challenges is in order to transact with the blockchain, you need tokens. And typically the way that's implemented is with a faucet. So we've automated the ability for you to fetch tokens for your developer experience. But the downside is that during the setup, it takes a minute, sometimes a little bit more to get those tokens. So when I type yarn start here, we're going to see, first of all, we're going to see more warnings because there are some issues that just cause those warnings to be generated with some of the Conflux libraries. But more importantly, we may have to wait a little bit for the faucet to be activated and to give us our tokens. So how do we do that? Well, let's clear the screen first and type yarn start. Now, what this is going to do is kick off all the orchestration that we have done to make things super easy for you. Literally, yarn and yarn start are the only two commands you use in order to get going. So let's do that. So this is going to fire up the server, a whole bunch of processes to launch the code needed in order to compile smart contracts, etc., deploy them to the testnet. And you can see here that it's now trying to reach out to the faucet. It creates test accounts. It creates about 6 to 10 test accounts. We kind of randomize that a little bit. But the most important thing is that the account 0, the first account we create, is the one that actually needs most of the funds in order to be able to deploy and do things like that. So what this is doing right now is it's waiting for the faucet to add funds to the account. And because it's a testnet, there's a possibility that sometimes it may be down and it might not respond right away. The only thing you can do then is to try again. And hopefully it will work fine here. If not, I have a backup project that already has some funding and we can launch that. So that's going to take a little bit of time. And in my tests, sometimes it's been as little as 30 seconds. Sometimes it's been as much as 2 or 3 minutes. But the first time is the only time you have to do this. After that, your account is funded, and so you're good to go. We'd love to speed this up, but this is a constraint that is part of the network, and we really can't work around it very, very easily. But there we go. So now we are seeing some errors, which means that actually we have gone past the funding step, and now it's the compiler giving some errors. These errors started with a recent version of the Solidity compiler that's there. You can safely ignore them. But you can see now that it is actually compiling the smart contracts, and it's going to do that momentarily, and then it's going to deploy them. And once that's done, we'll be able to go a little deeper into the code, take a look at that, and see what else is happening. Now, some of these things are dynamically generated, so depending on your bandwidth, it might also be a little slow. And right now, because I'm presenting, etc., a lot of my bandwidth is being used up for the video, so it might be a little longer than usual. But usually, when I'm doing this sort of without presenting and all that, I can have the entire project running in under 4 minutes. So let's say if it takes longer or is quicker this time. So while we are waiting on that, what I can also do is kind of dive a little bit deeper into these packages. And I have a couple of slides also I want to share around that. So in DAPlib is sort of the heart of this whole thing. And what it contains is the smart contracts and the unit tests and everything necessary to communicate with the blockchain. Now we are dealing with Solidity, and so the contracts are written here in the Solidity language. So it looks like we've got more stuff happening with the compiler. We're gonna try and figure out a way to suppress these warnings, because like I said, they only started recently, and it's due to a change in one of the underlying libraries. But I think we are past that. So you can see now that we are in the deployment stage. So the compilation is done. And what we are doing right now is actually deploying to the Conflux testnet. You would not be able to get to this point unless you actually had Conflux tokens in the test account that was generated. And that's where the faucet I was referring to earlier came. You can see that there's a cost associated with blockchain transactions. So if you're new to blockchain, that's one thing you need to be aware of. Anytime you do anything with a smart contract, or even transactionally, maybe sending funds or whatever, that changes the state of the blockchain, you're going to be paying for it, and that's called gas fees. So now we are past all the smart contract stuff, and we are essentially doing our client with Webpack, and bam, we are done. So Yarn and Yarn start, and we have dappiness. Now I mentioned to you that the faucet for the first account is what we prioritize, and then we hit the other accounts after that. So you're going to see this. You're going to see errors coming from the faucet because they have constraints about how often the same IP address can load, etc. But not to worry. If you just run yarn start again, it'll make another request at another time and fund it up. But you can see here that my account 0 did get funds. That's right there. And so the other accounts are for testing purposes. You may never actually need them potentially, but if you do, just run the faucet again. You can even type just yarn faucet, and it'll just run the faucet and feed it. But let's look at what we have here on the left. So this is our complete web application, a decentralized application that was generated for us. I mentioned that you have something called a workspace. So everything around here in blue, that's really our workspace. Your actual app is just in here. And if you want to see your app, your DApp rather, without the workspace, you can always click on this arrow up here to pop it out. Now, our goal is to make your life easier. And in order to make it easier, it's important that we give you everything necessary for you to be coding and developing as quickly as possible. So in addition to all this orchestration you saw on the right, where I didn't have to do anything other than yarn and yarn start, we also make it super simple for you on the web client integration part. We do that specifically by creating a UI test harness for every module you select. This UI harness gives you a complete UI that is fully wired to the blockchain so that you can actually start playing with it and experimenting with it. Different people have different learning skills and learning techniques. I learn best by looking at someone else's code and modifying it. And if you have that same thing, you're going to love it, because you can just go in here, tinker with the code, change it, and make it your own and enhance it as much as possible. So let's just test out this UI harness. So I mentioned to you that the contract run state allows you to pause and unpause that. So let's go ahead and see that. So what you are seeing here are action cards. So action cards are simply UI widgets we have that make it super simple for you to interact with the blockchain. And there's two. There's a view action card, which allows you to read information from the blockchain. And there is a submit action card, which allows you to change state. So the first thing we're going to do is query our smart contract and check to see if it's active. Obviously, my guess is it's going to be active because we just deployed it. And so let's do that. Let's go ahead and query it. And you can see that it reports back that it is yes. Now, as I go through this, you will see that we have optimized the action cards, etc., to be helpful to the developer. You can also use the action cards as is for the user with some small changes, but we really optimize it for the developer. Now that we have that, we know it's yes, let's turn it off. So we'll submit a transaction to turn it off. So we do that. And remember, this is going against the testnet, so it might take a second or two. And there we go. It's come back, and it has a transaction hash. Now, on blockchain, anytime you submit a transaction, you get a transaction hash. That is the unique identifier for that transaction. And because we are live on testnet, one of the cool things we can do with this is we can copy that transaction hash, and we can verify that this actually happened with the Conflux Testnet Explorer. So for that, I'm going to go to testnet.confluxscan.io, and it has a search box. I'm going to type my transaction in there and hit enter. And you can see that it's pulling it up, and it's saying there haven't been enough confirmations yet on this transaction. A confirmation, a good way to think about it is how many blocks have been hashed after your transaction. And now we've had 11 done, so it means it's secure. But you can see that I sent a transaction from a smart contract. So let's go ahead and look at this smart contract. So you can see that this was deployed about 5 minutes ago, which is roughly the time I've been talking. And here is the transaction we just submitted. So one of the nice things about Dap Starter and us working with testnet is you can verify instantly how things are working. You're not working with a fake emulator. You're working with the live blockchain testnet that's there, and you can see your transactions in real time happening and working on there. So this is one of the best parts about Dap Starter and working is we get you from 0 to working in as little as 5 minutes, but maybe potentially a little longer. All right, so what I'm going to do now, before I get into more code, is I want to give you a sense of the architecture of Dap Starter. So I'm going to switch over to a couple of slides I made, and we'll talk through those. So let's go right here. All right, so we've already seen the workspace, and we saw the 3 packages that are there. What I want to do is do a little dive deep into what you can expect to find there, and then we'll go actually look at those things. So let's actually start with daplib in the center, because it's actually the most important thing. So with daplib, you have 4 main components in there. You have the contracts. So these are the smart contracts that you're working with. And I say contracts in the plural, because while you can have just one smart contract, one of the things you're going to find out very quickly about blockchain development is that it's different from web development, where you can just make changes if you find a bug and upload a new version. Well, you can't do that with blockchain smart contracts because they are immutable. When you fix a bug and you upload a new version, it doesn't replace what's there. It is a whole new smart contract with its own data. And that data is an important thing for you to know about. Smart contract data resides with that smart contract. So if you upload a new version, it's going to essentially make the old one not used anymore. It's still going to be there. The data is there. And as long as you point a client to it with that address, it'll continue working forever. But your new code, you'll probably want to change your client to point to it. And that's not going to be a very good experience. So how do you solve that immutability problem? Well, you will see in the architecture of the Dap Starter project that we have split it up so that the contract state, the data, etc., resides in one contract, and the application resides in another contract. And what this allows you to do is to essentially switch out the application contract if you find a bug while retaining the state. And the two work together harmoniously because of the fact that it's designed to securely only allow your application contract to call into it and manage the state. And you'll see that in a bit. So there's that. The next thing that's important that you will find in the Dap lib is Dap Library. So this is a JavaScript library, and this is the library where you literally need to know nothing about blockchain. It's just a collection of JavaScript functions that interact with the blockchain and do all of the heavy lifting for you for your web UI. Now, how does this Dap library know how to interact with the blockchain, especially since our platform is blockchain agnostic? Well, that's where the blockchain proxy comes into play. This is a JavaScript library. It's actually just one file. And actually, Dap library is also just one file. Blockchain proxy has all the knowledge about the specific blockchain, in this case, Conflux, and Dap library knows to call into blockchain proxy. And we're going to dive into that in a little deeper in a moment, so you'll see how that architecture works. And finally, in the Dap lib package are also unit tests. So you can run unit tests using the Mocha framework with a chai assertion library. All right, now moving to the left for the client. Now, you saw the client I had. It was generated based on my choice of vanilla.js. Does that mean you have to use that? Absolutely not. You can discard our client completely. You can throw it away. You can just delete that package and start your own client. Maybe you've got your favorite set of code already done in there. You can just use that. There is nothing that requires you to use our client other than perhaps to get started, because we have architected this so that everything for the blockchain goes through one script file, daplib. So you can just import daplib into your client, web app, or even a mobile app or a React Native app if you want to, and it'll just work. But if you choose to use what we have, then you would want to kind of get familiar with it. So there are three aspects to it. There are pages. So a page is essentially what you see when you first go up here. So this is a page. This is your page. You can add as many as you want. And it's just an HTML page. There's nothing special about it. And you can add more and add them to the navigation. Then there's the UI harness. This is what I showed you in order to interact with the blockchain. And then there are web components. So in addition to the action card I told you about, there's a few more web components, which I'll be walking through here. Now, we use the Tailwind CSS framework. We really like it because most of what you do in Tailwind is you have HTML elements and you have classes, and you can create some pretty beautiful UIs with it. It's an API design system. I guess that's the best way to describe it. But you don't need to use Tailwind CSS. Maybe you like Bootstrap or Material Design or Bulma or whatever it is. You can use it. You can swap out this and use your own. We are not requiring any of that. In the HTML client, we use something called Lit Element. Now, Lit Element is, in my opinion, one of the best frameworks to create lightweight web components. And we didn't want to be too opinionated in the code we present to you. So we use Lit Element because in addition to being lightweight in making web components, it also allows you to have great color highlighting in code, as you'll see when we go into the code. So we definitely recommend that. All right. And then finally, over here on the right, we use Nest.js for a server API. There are some modules that have events. And what we do is we wire up those events with an API here so that when the event is detected, your server can do something. Maybe you want to update a database, or you want to send a message to someone, or you want to make a call to Zapier or something like that. Whatever you want to do, you can do all of that. And we also provide a Swagger UI for you to work with that, as you will see. Actually, I can just show that to you right now. So you can go here and you can see that there's a Swagger UI for trying out the exact same thing here. So we did is contract run state active. We can execute that in live, and you can see that it works, which reminds me, I did not run a transaction to turn my contract back on. So I should probably do that. So I turned it off, and the API reported it was off. So I should go ahead and turn it on before I forget. So we'll do that and let that do its thing and come back momentarily with the transaction. Great. And now let's go run this again. We'll hit execute, and the result is now true. So this is wired up and works, and it's great for testing. All right, let's take a look at this architecture. So over here, this diagram here gives you a sense of what we are dealing with here. It looks a little complicated, but it's really not, and I'm going to walk through it. So the dashed line here is your blockchain, and below it are your contracts. Then there's the blockchain proxy I mentioned, which is a script file which understands everything about the blockchain. Everything about blockchain proxy is common to all blockchains that we support. It's the same. It works everywhere. We engineered the blockchain proxy to be as familiar as possible to Web 2.0 developers. So earlier I told you, that blockchains have read and write. So what we did was we implemented the read as a get function, and we implemented the write as a post function. Now this should be familiar to any web developer who's interacted with a REST API, which is probably all of you. And then we have the concept of events. So that's all the blockchain proxy is about. Everything else about here is all JavaScript, HTML, and CSS, stuff that you already know. So it's that easy. So let's look at it. So Dap Library is the heart of it. The Nest.js API, server API uses Dap Library. The unit tests use Dap Library. When we created the unit test framework for this, we wanted to make sure that you test not just the smart contract, but you also test the client-side code. So the workflow pattern is to write your contract, then write the Dap library code for it, and then write a unit test to call that Dap library. And so what you do is you exercise not just the client-side code, you test that out, but you go all the way through and make sure the entire workflow is working correctly. Over here on the left, a look at what is happening in the client. So as I mentioned, there's pages, there's a UI harness, they have web components. The action card is the primary web component we use, but within that, the actual button that's there is a separate web component. So when you look at this UI here, you might not like it. This is not exactly the UI you want to do, and we wanted to take that into consideration, and so we made it so you can discard the button and the action card and just use the button, and the button can be CSS style however you want, but it is a smart button. It knows how to read and write from the blockchain in terms of submitting transactions and calling in there. So that's the action button. And in addition to that, we have made a number of different widgets that make your life easier. For example, let's go into this UI harness, and let's say that we go to the IPFS documents. You can see here that there's a widget for uploading files, which you can drag and drop, or you can just upload files. It'll thumbnail them and do all of that for you. So anytime we have a module, we've tried to make it complete. We've also got helper accounts here. So all your accounts are automatically generated, and they have easy to remember names. So you can use all of that. So that's a quick look at the architecture of the Dap Starter project. Now what we can do is start making some changes and go into the code here. So for that, I'm going to reduce this a little bit. This is probably a good point to let you know that if you have any questions, to post them, and Chase will be our moderator and let us know, and we'll have a section at the end where we'll answer any questions that you might have. All right, so let's start by exploring some of this here. And I think the best place to start for me always is dapstate.sol. So dapstate.sol is the primary state contract of the project. One of the things you'll see right away is there's a lot of comments. Those comments are for you to make it easy for you to understand the code that's in there. As I mentioned, if you're a Web 2.0 developer, a JavaScript developer, this might look a little familiar. So it's got the same syntax more or less. Of course, it's typed, so there are, and it's scoped, so there are types and scopes and things like that. But it should not be very difficult for you to pick up Solidity. So what you can see in this code here is the origin of different things. You can see that this particular thing originated from IPFS, and this thing came from access control. It tells you what's going on. So this particular smart contract is the primary smart contract, and it has all the functions, and it has all the variables and the data structures where data is stored. Now, dap.sol is the contract that calls into that one. And the way it does that bridging between Dap and Dap State is via an interface provided by iDap State here. So if you go into this one, you can see that it has all certain example functions that we have put to help you understand how to bridge between the two. You can ignore all of these and just do all your work in Dap State, and you'll be fine. You can just complete. In fact, you can just delete those also, and it'll be fine. So this is the way. If you want to start modifying things, Dap State is where you would begin modifying state. Now you can see here. Let's stay with our example of contract run state, right? It's because it's really simple to understand, and if you can grasp essentially that how contract run state does a read and how it does a write, you're well on your way to writing any kind of smart contract, because basically then it's a question of figuring out whether you're reading or you're writing. So I see a question already about, so Tailwind is a CSS framework, and yes, it is a CSS framework, just like Bootstrap. In fact, it is the fastest growing and most popular CSS framework that is there right now, because it's very modular and it's super simple to use, and it makes for really good looking web pages. All right, so there are events, and then there are functions. So when we choose is contract run state active, what we are doing is we are reading. So when I select this, it's calling this function, and you can see it returns a Boolean. So in my UI, I represent the Boolean as a yes or a no. So that's what's happening here. So how did I go from this web page to this function in the smart contract? We're going to go through that. But before we do that, I also want to show you the right one. So this one here is set contract run state. It's going to change. It's going to take a Boolean, yes or no, and it's going to change a global contract variable, contract run state. It's going to set it to true or false, and then it's going to emit an event that says the contract run state was changed. So that's it, those two things. So let's work our way through the stack into these two functions. So in my workflow diagram, I said that daplib is the way to interact with it. So that's a logical place for us to start. So for daplib, you go into the daplib package, you go into source and in lib, and you will find that there is the daplib file there. All right. So you can see that this first import it does is blockchain, And I mentioned that's the blockchain proxy. That's the only sort of blockchain related touch point there is in this particular file. Once you see this code, you will see that it's very formulaic. It's very patterned and super easy to understand. I'm going to walk you through it. So almost all of them follow the exact same pattern. You're going to asynchronously, so there's an await, call blockchain. It's a static method called get, and you're going to pass to it a few things. You're going to pass to it the configuration. In this configuration, we have things like, what is the URL, what is the address of the contract, and because you are in development, we have these test accounts for you with the wallets and the private keys. This is as good a time as any to talk about wallets and private keys. So in most blockchain projects, as a developer, if you're new to it, you're going to hit a massive brick wall instantly. That brick wall is wallets. Most blockchain development environments force you to understand how to get a wallet, how to set up an account, and all that. Having done a fair bit of blockchain development for so many different blockchains, I can tell you with 100% assurance that you do not need to take that approach. That is, in fact, a backwards approach to learning blockchain development. You don't need to get into the wallet aspect of it and the account aspect of it until you first got a handle around what you're building, your decentralized application, how it works, how the blockchain interaction works. And then you can get into the complexity of having the user authenticate, use their private key, all of that kind of stuff. So in Dap Starter, we made a conscious decision that when you start building, all the test accounts and all the private keys, etc., for you are automated. They are under the hood. They are there. And in fact, they are auto-generated for you at the, I told you, like, it's generating the test accounts and going to the faucet, etc. So when that happens, it auto-generates this file here called Dap Config. And that has the URL of where this is connecting to, the addresses of the deployed contract. So if I copy this address here and I go to the Conflux blockchain, you will see that, well, it's already there. So, but it brings up the contract. It also generates these test accounts for you. Now, one thing I want you to be aware of is that fairly recently, I would say about a month ago, Conflux changed its address format from the Ethereum type format to this new format where there's a prefix which indicates which network the account is on, followed by the actual address. So you may encounter in Dap Starter a function that is using an address that gives you an error. That is because of the address change. We are going through it with a fine-tooth comb and trying to make everything work out. But if you see that, don't despair. It's really very simple. Edit, and in fact, the error message will tell you what to change, so you can change it. But be aware that the address format has changed, and as a result, there might be a few errors that, and we apologize for that. We never want you to experience errors, but because of this address change, it might happen. But you can see here that the wallets, public and private key, etc., are all in here. We are well aware that private keys are not something you share, but these are test accounts in a test environment for learning development. And we felt that it was much better to have this auto-generated file in here and have everything done for you versus trying to educate and explain about how the workflow for that works. So once you get to the point where you understand this stuff and are better with the development, you can then start interacting with our wallet, and you don't need to use these test accounts, and you can use your own accounts. There's nothing that requires you to use these. This is just for the development purposes. Okay, back to DAPLib. So config gives you all of that. The contract that you're trying to call. So we have global constants set up for both the Dap state and the Dap contract. So you can just use that. And then any parameters. So as you get into deeper development here and are ready to move to beyond testnet and beyond the dev wallets, this from here, you'll want to change it to the current user. And that's a minor change to make. But based on the user's browser and the wallet they have, you will put that from in there. So dynamically look it up. If you put null here, it's an indicator to Dap lib to just use the default wallet, which is the first wallet here, the first test account that's there. That's what null means. Just go ahead and use that. Okay, so you've got most of this here. And then the next parameter here is which function in the blockchain smart contract you wish to call. And the contract one we had, I should actually pin that open so we don't have to keep closing that. So let me do that. Keep open and do this. Okay, so is contract run state active? So that's it right there. This is what it's named, and that's what we are calling. And then one of the things we've done is we've taken the return values. And if you notice, when I was interacting with this, it has a little formatter. Even when the transaction ran, it gave you a nice little icon to copy things, etc. So we have a bunch of formatters here. This is just syntactic sugar to make it easier for you to read stuff. You can ignore it. The actual result is right here in result.call_data. You can ignore everything else. But every function in daplib has the same pattern. The only difference is whether it's get to read or post to write. Now, obviously, when you're posting data, you want to submit the user's input. So how does that happen? Well, that comes in as child properties of this one object here, data. So set contract run state accepts one property, one input variable, the Boolean, that will change the run state from true to false. And so mode is that input. And you can see that that's what we are submitting here. We want to submit mode. Of course, you could have called it anything you want, but we wanted to be consistent. Now, one thing that I'm going to tell you, which no one told me when I first wrote a smart contract, is that it is pointless to wait for the return value of a blockchain transaction. All you will get there is a transaction ID, a hash. That's it. You can never return anything from a blockchain smart contract. The reason for that is because it's completely asynchronous. You have no idea when your transaction will be executed, if it will be executed. So then how do you query for a result? Well, what your smart contract function should do is emit an event. When you emit an event, the data associated with that event is written to the blockchain's log, and that in turn you can monitor that. And when that event happens, you can have your application respond to it. Remember earlier I told you about how we have the server API that is monitoring events and can respond to it? That's exactly what you would do. So you can do that. You can also have it in the client browser. You can use a library that is just sitting there and waiting for events to occur, and you can notify the user when a transaction is complete. The other thing you could do if you wanted to, which is not advisable, but you could also poll with one of the read functions. You can just check to see if something's happening. Not ideal because it's bad use of resources, but if you want to, you could do that. But the takeaway, smart contract transactions that change state do not return any data. All you get is essentially what's called a transaction receipt or transaction hash. And that's what's happening here. And so when I submit this, you saw that, the hash, and I went back to the blockchain and looked up that. All right, so let me just look at a couple of more questions here. CFX can sponsor a contract. Can they be done using this generated code? So the question is, will Conflux sponsor a contract that was done using this generated code? I'm not privy to the details of what the sponsorship is, but the code that you're seeing here is open source MIT licensed source code that is high quality, written to be secure and performant. You can use it in any location where you need to use a smart contract? So I would say yes. Can smart contract generated be upgraded later? So this, as you're seeing here, once we give you the project source code, you can do whatever you want. This is licensed for you to freely do whatever you want with it. You can change it, delete it, package it up, do whatever you want, add to it, remove from it, anything. There is no constraint whatsoever. Once it's generated, it's done. You might also, like, for example, you might think about it as like create React app, right? Let's talk about that a little bit. With create React app, when you generate an app, you have to actually make a choice at some point to eject that app. And then it's free from the create React. This is not that. This is different. This is raw source code in the project that you can change as you want. There is no eject or anything like that. It is all there. You do what you want to. Okay. So remember I said that blockchain has had get, post, and the ability to respond to events. So here we go. We got an add event handler, and you can basically have a callback that happens when that event occurs. So all of this here is JavaScript. We are moving up the stack. If basically we've started with the smart contract, now we've got the library. This is Dap lib. It houses all that. Let's now move up the stack into the client UI. Now, that's in the client project here, and we can go into source and Dap, and you'll start seeing some of the things I've talked about. So pages. So dap.js in client, source, Dap, pages is the page that you see here that says dappiness. It's right there. And remember earlier I told you about lit element. This is lit element here. What it allows you to do is annotate your HTML, your JavaScript, and render HTML with attributes that do a whole lot. So, for example, here you can see that this is just a JavaScript template literal, and it has HTML code in here, but it is color highlighted. Now, one of the things we do as part of the orchestration and our goal to make life easy for you is everything here is packaged up with Webpack, and it's set to be hot loaded. So when you want to make a change and hit save, and you're done. It just works. You can do the same thing for the contract also. It will redeploy and do everything when you save automatically. You don't even have to think about it. Nothing to do. This is how it works out of the box. So we've also made it so that you can easily take any of the code or any of the components we have in here and put them into your Dap. So the test harness, the UI test harness is something we think or we know you will delete. It's not something you want in your app. It's there for while you're developing. But there's no reason you can't borrow this code. So let's go here. So for example, you want an action card. Let's take this one here. I will copy it, and I will go to my dap.js, and I'm going to get rid of all this stuff here. And we'll just paste our action card here, and we'll hit save. And there we go. And nothing to do. It just works. It works just like that. So now you can make changes much easier. So this is as good a time as any to tell you about the magic of the action card. The action card is very, very simple and easy way to read stuff. You give it a title, you give it a description. So, and again, this is just basic stuff. It'll hot load and work. You give it an action. This action here corresponds to what your dap lib function name is. So I consistently named things the same way so that we could find out easily, but I'm just going to go back here. So this is contract run state active, and that's what is in dap.js. And the method we want to use is get. So you can either use get or post, and that's it. In the case of an action card, this is all you need in order to generate this UI and query any kind of blockchain get function. And recollect that in my data with daplib, I return a Boolean here, but we've provided helper functions for you. So if you want to return, for example, an array, or if you want to return, there's a ton of helper functions. I'm going to show you here. Let's get to those. There's arrays, objects, etc. So everything about daplib here is there's a lot of helper functions. Here we go. So you can see that there you can return numbers, you can return hashes, you can return arrays, or you can return just an object, and it'll automatically format and present it to you as a nice grid. Remember, action cards are designed to make developers' lives easier, but it doesn't mean you can't use it in your UI, in your production application. So that's a read. Let's see how it looks like for a write. So going back to our contract run state, now this is where it gets a little more interesting. So I'm going to go ahead and first move it into my dApp page, and then I'm going to elaborate on how it works. So let's make a little space here. All right, so this is an action card that is going to write to the blockchain. So title, description, same deal. Action, same deal. This is the function that is in daplib, but the method. So method is post. And now here is the extra thing that is not in get, it's just fields. So this is a space-separated list of all the input elements that are child elements of this HTML element. So in this case, you can see that I have something called a switch widget. So a switch widget is just a checkbox. It's a custom component, and it has a field name of mode. And guess what? This field mode matches this mode here. Now I could easily add something here. I could say input type equals text, data dash field equals demo, and leave it at that. And let's hit save. And we got that. Now there is an input field here, but I didn't put any styling, so you couldn't see it. Now, what's going to happen is that because I put that field there and I added data field, the action card is going to capture that, and return it to daplib. But I still need to tell it, and so I need to tell it what that data field is. And so we'll put that demo there. And so now there are two fields. I'll save that. I should have done that before loading the page, but here we go. Okay, so we want to see this input. We want to see it in action. So how are we going to do that? Well, we know that this action card here is calling set contract run state in daplib. So what we can do is we can just write that out to the console. So we go here, and what we'll do is put a console.log data here. We'll save. That's recompiled and redone. And let me just shrink this window a bit and pop out this here so we can see the console. And we'll clear all this debris here. Okay. And we'll type hello and we'll submit. Now, we're doing nothing with this hello. We are just going to ignore it. We are not submitting it to the blockchain smart contract because it doesn't know or need a string. It just needs its Boolean, which we actually removed, but that's fine. So we'll hit submit here. And let's see, I got an error. So, oh, there we go. I expected that error, but here's our data demo. Hello. So it is written by console log. So that's exactly and how easy it is for you to wire up from the UI down into the daplib. So this is, in a nutshell, the entire sort of Dap Starter user experience. Many people don't use the server, so I won't spend time there, but it's fairly easy for you to go and see that it's a standard sort of Nest.js kind of application. So I think that pretty much covers all the topics that I wanted to cover. We've gone through how to generate the contract, how to use it, how to modify it, etc. And I'm going to turn it back over to Chase now, who's going to tell you about some exciting new developments that are coming up. Let's see how we can switch this over.
You should be able to go to the screen that you're actually sharing, and on the bottom there should be something that that says stop your screen sharing.
Oh.
Or maybe I could try to share my screen and see.
Oh yeah, here we go. I got it.
All right, there we go.
Great.
All right. Can you see my screen? Yes?
Yes.
Beautiful. So now that you sort of know the lay of the land, and Nick has walked through how to use Dap Starter, I want to share some super exciting news. So it's no secret that NFTs are blowing up, and it's sort of the time for NFTs, and we're super excited about that. We've actually been working on NFT tooling for Dap Starter for a while now. So we're finally at the point where we are ready to share that tooling, and we are super excited because Conflux is actually going to be one of the first blockchains that will be supported with our NFT tooling. So what we're building is called NFT Studio, and basically what it allows developers to do is not just build, apps with NFTs in them. It's intended to be really like a fully functional and by far the most extensible feature module within Dap Starter. So I won't go through all of it today because we've saved a couple exciting things for next week. But the basic concept behind NFT Studio is that developers can go in and they can choose sort of a foundation. So we'll start with collectibles, the ability to unlock content based on whether or not someone has an NFT, so gated access essentially. And then we're actually also going to have an RPG foundation, which probably won't be ready in the first release, but we're super, super excited about that. And then developers will actually be able to go through and choose the minting models that they want, what types of metadata they want stored within their NFT or associated with their NFT rather, the generator mechanism. So whether you want something to be genetic, which is more like a CryptoKitty, or have like a pack that has a drop, which would be more of a set. And we're also working on marketplace functionality. So we're really working on building out a highly extensible NFT feature module. And what we're excited about is that this is going to be launching next week. So what we're going to be doing is part of this launch will actually be in collaboration with Conflux. We're going to be doing a mini NFT hackathon. So we're going to do our first official release of NFT Studio on April 7th, which is exactly when this hackathon is going to be kicked off. And essentially what we're going to do is we're going to have this sort of mini series of, we'll have a webinar next week, and then we'll do a couple office hours. And all of these details will be in next week's session. But we're going to walk through next week, April 7th, how to build NFT-enabled applications using Dap Starter with what will now be the new NFT Studio module. And then we're also going to sort of use that as our kickoff for this mini hackathon. So we'll share information about the dates and the prizes and all of the details then. The cool thing is that if you are already registered for this crowdcast, you're actually going to be already registered for next week's session. So we're sort of, it's sort of session 1 of 2, and next week will be session number 2. If you are not registered, or if you want to, put it in your calendar, absolutely please do so. So it'll be at the exact same time, just next week on April 7th. And we are really, really excited about this mini hackathon. It's going to be an awesome opportunity for developers to not only sort of play around with NFTs, but to also start really pushing Conflux and trying to build some really innovative and interesting NFT-enabled applications. So it will be a 2-week hackathon, or maybe 3. We'll have all the details next week. But it is a really good opportunity to start building, to play around, and ultimately to build some really cool stuff. In the meantime, before all of next week's session, please be sure to join our community. I've linked the Discord here. And of course, the Conflux Discord will also be a great place to find information about next week's session. But we're really, really excited to be sharing this sort of NFT first and having Conflux as one of the first blockchains that will be supported. So thank you everyone for coming. I know we want to open up the floor for questions. And actually one of the first questions that I want to address and answer now is I see a question about sort of like low code. The question is asking about creating smart contracts and dApps being as easy as, someone's mom being able to do it. So the question ultimately would be, are we trying or are we going to create simple app templates? Our basic philosophy right now is that we believe that blockchain is still pretty early for like low or no code completely. That doesn't mean that it won't be that way in the future. It just means that our current plans are to serve developers, which, we believe will probably be the first iteration of applications that will really like change the game for blockchain. From there, though, once there are clear needs for people who are building without writing a line of code, that's something that we'll definitely explore. It's challenging with smart contracts, as we've talked a lot about, because you want to make sure that smart contracts are efficient and all that stuff. But right now, we're focused on developers. Long term, we could certainly potentially do that.
Yeah, a good way to think about it is look at the mobile app ecosystem, right? It's only now that we are starting to see, platforms, etc., that allow you to do no-code mobile apps, and those are also still fairly constrained. And the reason for that is the user experience for some of these is complex. You can't expect a user who does not have the professional training and the background in doing this to create something beyond rudimentary stuff. So even if there's going to be no-code blockchain things, they're going to be fairly simplistic, I think. And they will be mostly, I predict, multi-tenant SaaS applications where you use someone's published smart contract to do something for yourself. Maybe you create a social token, or you already see like OpenSea, Wearable, etc., doing NFTs and things like that, right? So you're going to see that. But no code is, I think we're still a ways away from that, as Jay said.
Yeah, it's an interesting question, though. We've certainly thought a lot about that as a team, and it's definitely something where, we're not sure what 5 years from now blockchain is going to look like, but we are absolutely dedicated to serving people who are building applications. And right now, our hypothesis is that is developers, but if that changes, then that's absolutely something that we'll build for. Are there any other questions? It looks like we covered all of them. Sweet. Well, hopefully this was a useful session. Please make sure to mark on your calendars this date, April 7th, because it's going to be a really, really awesome session. And we are super excited to be sharing this with the Conflux community. I think it's going to be a really cool opportunity for people to be able to start building and really just experiment and try interesting and new things. We're seeing that a lot in the NFT space, and we're hoping that our tooling can help with a lot of those pieces. So hopefully everyone has a wonderful rest of your day, night, wherever you're watching this from. And thanks so much for watching.
Thank you. Thank you so much.
Thanks, guys.